You're good.
All right, this is John and Matthew back for part two. We had question 6, which asks us to explain the steps that lead to an extinction vortex. An extinction vortex begins with a small population size, and that small population has little or no gene flow. This leads to genetic drift, which one of the effects are random fixations within the population.
Perfect. And because this question's a little more elaborate, John and I thought we'd share a picture with you just to kind of push this along. So I hope that you can see this picture. So basically, as John stated, with that genetic drift and that random fixation, there's little or no gene flow. It also leads to a loss of the heterozygosity within a gene. So those random fixed genes usually end up in one of the two extremes. You either end up with dominant homozygous alleles, or you end up with recessive, and in this case, deleterious recessive alleles that cause even more problems. This basically leads to an inbreeding depression. You get lower reproduction, higher mortality, which leads to an even smaller population, and the cycle just gets worse and worse until eventually the animal goes extinct. Well, I hope this was entertaining for you watching. I'm sure we'll be entertained by your screencasts, and we'll see you next week.